Hello, I'm Lee. In this video, we are going to look at the usage of STL, Standard Template Library. So when I use STL, I use this website a lot, c++.com. So if you click on the reference link here, you will see STL containers and STL algorithms. So the standard template library contains three big parts. The containers, such as vector, list, stack, queue, map, those typical containers, just like in the Java API. And STL algorithms, like the algorithm to manipulate the containers, the items in the containers, such as sorting, shuffling, searching, that sort of stuff. And the third one is the iterator. The iterator help us to iterate through the items in the container. So for example, if I want to check out one kind of container, when I click on STL containers here, it shows us the three different type of container, the sequential ones, the associative one, and some adapter. You will see like a stack. We can use vector for a stack, but stack is got some limitation there. So it's kind of like an adapter. You can read in detail about that one because it only gave you last in first out order there. And for example, if you want to check out a vector, the most frequently used container, if you click on vector, here's a description of this vector and the member function, the iterator, everything. And for example, if you want to know how to add something to the stack, like add element at the end, if you want to know this one, click on this one, and it shows you the prototype, the detail, and I found the example part is very useful. Lots of the time, just skip the description and come right to the example part because we read the code faster than read the English descriptions. And we only read the descriptions when we have we want an accurate description because the example code only show us one kind of usage. So if you want to know some boundary conditions, some special cases, you should still refer to the documentation here. So you see in the example code, it shows you how to create an integer vector and how to populate the vector and how to take a look at the size. So the typical usage about how to use pushback. So it has a sample code for every function. For example, if you try to look at the erase function, you just click on the erase function and the example code here. So I found this website very easy to navigate, especially for the STL part, the STL container, STL algorithm. It provides simple and straightforward sample code for you to as a reference. So now let's take a look at the sample code I put together here. We still use the student class, and the student class has two mutator methods like setID and setGPA, get ID and get GPA, and a print function. A print function just for convenience, like if you give me a output stream, I'm going to write out my state to that stream. So pretty much that's the same with the previous lessons. And now let's take a look at the STL usage. So first of all, I have a global variable. It's an array of pointers to student. And we populate the array by allocating those memory. Remember, new student gave you back the address of the newly allocated students. I put it in as a one element in the array. That's a data type for individual element in the array. And also I find out the size of this array by doing size of this array. It gives me the size of the array and size of individual element of the array. So that calculation gives me back the size of this array. I do it this way because later on, if I decide to add a couple of new students there, this size is still working. So if I just put 4 there, that's too fixed. So if I calculate on the way, that's better. All right, and we're going to use this student array to populate our STL containers. And this array contains pointers to students, and that's what we're going to do. We're going to put pointers to the objects inside the STL containers instead of the objects itself. So because it's much more flexible, think about if we put pointers in the STL container, when we move the pointers around, it's much easier than moving the objects around. So most of the time when you use STL container, you put pointers of the objects in the container instead of the objects itself. So now let's take a look at useVector. So we create a vector of student. This is called a template. So it could be a vector of int, a vector of student object, a vector of, here I put pointer to student object. So that means the vector is supposed to hold pointer to student object. And I use a pushback function of vector to add element to the vector. The element is array element. Remember, that's just pointer to student. And then when I loop through, I can use this bracket operator. You see, this operator is overloaded for vector, so I can use it this way to access individual element. It's overloaded, that means it acts just like a regular array, but you know student isn't an array, it's a vector. So behind the scene, vector is implemented by using array, but students isn't an array, it's just a vector object. But that vector class got bracket overloaded. How do we know that? Let's take a look at this website. It should talk about that one. So if we click on container, click on vector, and scroll down, you see operator bracket. It allows you to access individual element. Here it shows you how. And here is a usage of iterator. This is how you declare the iterator. I call it 8. And iterator, you can imagine iterator is a pointer to the element inside the container. So you see, we start the iterator with this one, student.begin. That function gave us an iterator. And then we check if we hit the end by doing this, and iterator plus plus, that incrementation operator is overloaded as well. It will move the iterator to the next, to point to the next element. So when we try to access the current element, we first dereference the iterator. Imagine the iterator is a pointer, so we have to dereference the pointer to get to the element we store in the container. So remember, the element we store in the container is a pointer to student object, so we have to use a big arrow print here. And student.clear will remove everything from that vector. So that's how you use a vector. And similarly, I put together a use map one. The use map one, when we insert a pair, the key value pair. So this pair is string as a key and pointer to student as a value, and here that's a key, that's a value. So we use whatever we put in the array to populate this map. And again, how to use the iterator in the map. This is how you declare the iterator. And similarly, begin give you the pointer to the first element, and this one give you the end of the element, end of the container. And to access the pair inside of the map, you say dereference 8, and you're trying to get the first, that's a key, and the second, that's a student, and that's a pointer to the student. Then you do the print. Because it's a pointer, you have to use big arrow. Because this is a pointer, you have to use big arrow. And that's the first, the second from that pair. And how to find something? You give it, you use a find function and give it the key. It will give you back the pair, and you access the second, the value part of the pair, and print it out. And here I put together a sample code for use algorithm as well. We use integer vector, for example, here, and we populate the vector. And the for each function just say, give me a range in that container, and I'm going to use this function on every element of it. So for each element between those range, I'm going to pass that element to this function. This is called a function parameter. Let's take a look at the print int. So you see here, print int says, give me an integer value. I'm going to print it for you. And the implementation is trivial. So that's print int, just see out value. So when you use the for each function, you give it the range of the container and give the function you want to use for every element. So it's just you want to print out individual integer. Remember, print int takes in an integer as a parameter, so that integer comes from this container. And we do some shuffling, and we print again to see the shuffling effect. And how about the sort one? The sort one, we can give it the range and it will sort it for us. How about, that's for integer, so it got a natural ordering. How about our student vector? Take a look at the student vector. The student vector, this time we create the vector by using the array. We give the range of the array and create the vector right away. So that's another way to populate a vector, use portions of the array. And then we do some shuffling and do some printing. And here, how to sort it. When we do the sorting, we need to give the range, and we need to give it some function parameter here about how to compare to students. So take a look at compare student by GPA. Compare by student by GPA says, give me to student pointer. Remember, that's what we put in the container, pointer to student. Give me 2 pointers to student. I'm going to compare them by GPA. The implementation is trivial. Let's take a look at the implementation. It pretty much it just compare the GPA here. So when you use the sorting function for student, you have to tell the sorting function how you're going to compare them by either passing in a function parameter here. Another way is to pass in a comparator object, comparator by ID. Let's take a look at the comparator object. They're equivalent, so either way is fine. So this is how comparator by ID got created. You call it any name, call it struct. That looks weird. It seems like a class, but yeah, that's a syntax. And this is a function name. You cannot change that name, and pass into pointer to students and do the comparison. So you can pass this one as a third parameter to do the sorting. So that's a sorting algorithm, and pretty much that's a sample code for how to use STL. Again, when you have questions, you can always come to this website and refer to the sample code. And when you have doubts about some boundary conditions, about some parameters, you can read the description. Thank you.